So we've got that taken care of. And so today we are going to do a return to math skills. We've been taking a lot of time with teaching techniques. We've been talking about different things with that. Now we're going to switch back to some math for you to do, and that is a review of the U.S. customary units. Keep in mind what's our theme. I'm going to refer to it back and forth, and we've been mostly dealing with teaching methods and teaching ideas and doing visuals and so forth. But keep in mind, I'm going to review this for you, but the whole time, since this is still primary math, what do we have to do? We have to realize that we are teaching from scratch. So if we're teaching measurements, we have to teach from scratch. We're teaching fractions, we have to teach from scratch. So we have to be aware of what they know and what they don't know. We will spend a whole lecture on teaching primary measurements. But today we're going to go beyond primary measurements and make sure you know your U.S. customary units. Make sure that you remember your measurement conversions. You're going to do homework, you're going to take a quiz, and so be sure that you, in your mind, know in the textbook 8.1 through 8.4. Notice we're just doing the A sections, just to get the measurement conversions back in your own mind. You should be very familiar with inches, feet, yards, and miles, and the conversion facts between them. Don't forget 5,280. That's probably the only one you may not have done a lot with. You'll notice that we're only doing the A sections, and you'll notice that we're not doing any compounds. That's not really part of primary math. That's taught about 6th, 5th grade. So we'll just center in on you being familiar with the English system or the U.S. customary system or the American standard system, whatever we want to call it. So before we even begin with this, I want to show you the fact that when we're doing U.S. customary, we are going to be doing fraction math. I heard a couple of you say you've already done the homework, but make sure that you used fraction math. So that means that any remainders are going to be in fraction form. That means the computation should be done using fraction multiplication. All right? And that I'm not going to take, if you wrote 1.5, I'm going to mark it wrong, because 1.5 is a metric, is a decimal, and 1.5 is used in the metric system. It is not a fraction. So on page 341, the length section, doing basic U.S. customary unit conversions, we don't have to be a 3rd grader and do larger to smaller, multiply. Or we don't need to be a college student and flip a coin in our mind. Am I going to multiply by 12 or divide by 12? Actually, we're going to use cancellation of units technique, and I showed this to you last semester. Here it is again. We're going to do fraction math. We are going to set up 2 fractions. The first fraction will usually be over 1. This is where we're going to take the given unit, and then the conversion fact, and multiply it. And the unit is going to tell us whether we multiply or divide. You say, well, I can convert from inches to feet. I hope so. But later on, when you start doing other conversions, you're going to need the cancellation of units technique. Several intermediate students missed one of my metric to English conversions. They divided by 2.2 to convert from pounds to kilograms instead of multiplying by it. Okay? Because you don't want to sit there and flip a coin mentally. Do I multiply or do I divide? This technique will tell you what to do. Especially if you have to do, there is 8 quarts in a peck, right? And 4 pecks in a bushel. You might want to write that one down because you might see it from me. 8 quarts in a peck. This is dry measures. 8 quarts in a peck. 4 pecks in a bushel. Bushel is an agricultural unit? It's a dry measure. All right, so let's say that I am converting 29, what am I writing, 8? 29 yards to feet. Obviously, I'm going to multiply, but I'm going to do it in fraction form, so I'm going to use the conversion fact. 1 yard equals 3 feet, and I'm going to write it in that order. Here's the conversion fact. This is how you convert measurements that you don't really know who's who and what's what. Okay? So I'm going to set this up as a fraction multiplication problem, and I'm going to put the conversion fact in whatever order necessary to make the units cross cancel. So what does this tell me? I'm going larger to smaller, multiply, but I don't have to do that. Okay, that's a crutch. Okay. So what do I end up doing here? I end up multiplying 29 times 3. So this is not going to, and units are part of the computation. Don't train your students to just plop it on the end. Try to make them write it all the time, write it through the problem. Then they're going to be less likely to leave it off on the answer. So I'm going to get 27, carry the 2, and I'm going to get 87 feet. Okay? If I was going the other way, 29 feet equals how many yards? My fraction would be different. I'm using the same conversion fact, but now I want to convert out of feet, so I write the conversion fact so that the unit cancels. So this tells me to divide by 29. And this tells me that I have an improper fraction, and if I work it properly, I'm not going to be tempted to go to the decimal. I'm going to do what? I'm going to make this a mixed number. 3 goes into 29 9 times, which is 27, with 2 left over. Then I'm going to get the appropriate mixed number. No decimals allowed, especially in this case. Why do I not want the decimal? Why do I not want the decimal? It repeats. 6, 6, 6, 6, 6, 6, 6. So it's inaccurate when I round it to 0.7 or 0.66, or I put a little dot. That's not the answer. The answer is 9 2/3 yards. That is how we're going to do the math. We're going to keep it in fraction form, and then we can do multiplication all the time. And then we can also cross-cancel numbers if that applies. For example, what if I have this conversion? Let's say I want to do, of course we know that 1 foot equals 12 inches. What if I want to do, let's do 38 inches equals how many feet? Let's convert inches to feet. 38 inches to feet. In my conversion fraction, I have my given fraction, my conversion fraction. I'm going to set this up so that my inches cancel out of, cross cancel. This is fraction multiplication. I'm going to set it up so that my inches cross cancel out of the problem. I can also do what? Reduce with the 12 and the 38. This becomes cross cancel a 2. Cross cancel another 2. So then I'm going to end up with a improper fraction, 19/6 feet. This is going to put me through the fraction math properly. This is how incompatible units with odd numbers are converted, through fraction math. So this will be 3 1/6 feet. Again, I have a fraction that would be a repeating decimal. Do not use decimal math. Do not use decimals when it has a remainder. Okay, if I divide 6 into 18 and add a decimal, I'm going to be there all day, or I'm going to end up rounding. The answer is not 3.2. The answer is not 3.17. The answer is not 3.167. The answer is 3 1/6. Right? Because when you do, I don't want to see any decimals. When I do the division, I'm going to go with fraction format, not decimal. Okay? Don't do it. Schoology won't accept it, and I won't either. That's what I mean by U.S. customary units. The conversions are done in fraction math, and we're going to use the fraction to help us decide if we multiply or divide. We don't have to decide. The problem tells us, and it also keeps it in the proper format and expresses the remainder properly. So no no decimals allowed, all fractions. What if I have to do this? Let's say I want to do 2.5 yards equals how many feet? Fraction math, and in fact, specifically, fraction multiplication. What goes in my given fraction? 5 halves. 5 halves yards. 5 yards over 2. Just like any time I'm multiplying fractions, I change my mixed numbers to improper fractions. All of this is fraction based, so you don't want to be just arbitrarily doing it off the top of your head and doing all these little scribbles, divide here, multiply here by scrap paper. No, you want to learn how to do conversions properly. This is how conversions are done in upper levels as well. And then I'm going to take my conversion fraction and I'm going to set it up. I'm going to write yards on the bottom, feet on the top, so that they will cross cancel. By the time they're in 7th grade, they have to use this technique. I have problems with it. Some of them, they do what I just said. They put the yards on the bottom and the feet on the top, and then sometimes they'll even do this. It's called not paying attention to what I'm doing. A very big problem with junior high students. So pay attention to what you're doing. We're going to do 3 feet equals 1 yard. We're going to cancel the yards out, and we're going to do the fraction multiplication. So I am going to get 15 over 2. 15 halves feet, and that's a simple improper fraction. It's going to become 7.5 feet, and then I've got the problem set up correctly. I've got the fraction correct. I've got the answer correct. And I'm also learning how to do conversions. You say, I can do this in my head. Maybe not, because the fraction makes it a little confusing. You can say most of the ones on the homework, I can do it in my head. Don't do it in your head. Practice using the technique so that if you have to use it with harder numbers later, it's not going to be a problem. Okay, so do your homework like a college student, not like a 3rd grader. Okay. One of the problems with this class is we don't have a lot of math skills grades. So if you have some poor math skill grades, it's going to hurt your average. So if you look at page 345, there are going to be some fractions involved and so forth. Especially, what if I have this? 7/8 of a foot equals how many inches? I'm really forced into using fraction multiplication. But that's okay. This helps me know that I'm going to actually multiply by 12, and it helps me with the computation. I'm going to cross cancel the units and any appropriate numbers. So 4 goes into 12 3 times, 4 goes into 8 twice. This is going to give me the improper fraction 21 over 2 in my inches, and then this is simply going to be 10.5 as a mixed number, 10.5 inches. That should make the math easier. when there's fractions involved. Yes?
I don't know if this is a really stupid question, it probably is, but why do you put the feet on the top and not on the bottom?
Because if it was on the bottom, it would be per feet. For example, rates have the unit on the bottom. I'm putting the feet on the top because it's a whole, it's in the numerator, it's feet. It's not per foot. So let's say, let me help you with that. What if I had a common thing in physical science is feet per second when you're doing momentum problems and acceleration and all kinds of things we don't want to do, right? So it would be 3 feet per second. So only when we have a per second or whatever does it go in the denominator. This is a whole foot. I know the numbers aren't. It's not 7 feet, it's 7/8 of a feet. 8 belongs in the denominator, 7 does not. Other thing you might see, of course, is miles per hour. Only when it's a per does it go in the denominator. That doesn't apply here at all.
It'll always be in the numerator.
Yes. Unless it's a rate. But not in primary math. Okay. All right, so you're going to be doing conversions with pretty much simple stuff, but it would be a good idea to practice that. Then you will also have to deal with units of weight. And of course, everybody knows, I hope, that 1 pound is 16 ounces and 2,000 pounds is a ton. So you'll be doing the A exercises only, but also this still applies. Use your fraction multiplication. For example, what if I have to convert 45 ounces into pounds? Oops, not equals. Not doing a proportion. All right, I know that there are 16 ounces in 1 pound. This is an awkward conversion. So in my given, I put 45 ounces over 1, and I'm going to set it up so that the ounces cross cancel with the ounces. 1 pound is 16 ounces, and this gives me a rather awkward fraction. I will convert it to a mixed number, not a decimal. Everybody's first impulse is to put the zeros in the decimal. Don't do that. We're going to get the exact answer as a mixed number. 16 is going to go in here twice, which is 32. Oops. 13/16 pounds. Kind of an awkward answer. But this is the U.S. customary units. They are very clumsy, which is why the metric is much easier. And we would not be dealing with seems like we wouldn't be dealing with almost half of our primary math if we didn't have to deal with the English or U.S. customary units. We wouldn't be memorizing all those flashcards. We wouldn't be learning all these odd things. We wouldn't have this awkward math. When do they do conversions? Grade 3. We'll talk about how to teach We'll talk about teaching, how we teach this later. Capacity, 8 fluid ounces in a cup, 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon. Those are very similar, or not similar, very familiar to you as well. But we are going to continue the theme of fraction math, whether it's going to be whether it's going to be ounces to pounds or fluid ounces to cups and so forth. What I want to do here is deal with, sometimes we will have to do a multiple conversion between more than one unit. And so we can do a mammoth fraction problem. Half gallon is how many ounces? Notice too that I'm always writing in cursive. Put your units in cursive so that you can tell the difference between L and 1 and O and 0, and you can tell the difference between Z and 2, B and 6, A and 9. I'm always telling the high school students that evolution occurs constantly in Algebra 1. X evolves into Y, and sometimes we have reverse. Y evolves back into X, A evolves into 9, and 9 evolves into A, 6 evolves into B. So I don't use B, I use B. All right, I don't use Z. Actually, I do, and I put a little thing through it out of habit. But use cursive when you're writing letters in math. Lowercase, unless it's a vertex, then you use uppercase, and that's print. It's kind of, math has kind of evolved that way. Uppercase is print, lowercase is cursive in math, okay? Also, math is kind of evolving. No longer are you going to see periods behind even US units. It used to be metric, no period, US periods, so less and less. So I'm still in the habit of putting the period. It's no longer written in your textbook, if you notice that. All right, so what if I want to convert half of a gallon? How many ounces in half a gallon? Fraction math. This is 1/2 of a gallon. Oops, not I don't really go from gallons to ounces directly, do I? I'm going to go down to quarts. Then I'm going to go down to pints. Then I can go down to ounces. So I'm setting this up so that I know that 4 quarts is a gallon. I'm setting it up so the gallons cancel out. And then I want the quarts to cancel out, so they're down here. And I know that there are 2 pints in 1 quart. Then I want the pints to cancel out, and I know that there are 16 fluid ounces in 1 pint. Okay? There's 8 in a cup. There's 2. You could go through cups if you had to. But I think I've got enough fractions up here, don't you? So all of my units are gone except ounces. I can get rid of the 2 right away by cross cancellation. So I'm going to end up with 1 times 2 again, which is 4. 4 times 16 is 64 ounces. So recommended daily water requirements is half a gallon, 64 ounces. Okay? So we can do multiple conversions in one step if we use fraction math. Okay? Because we don't have memorized. We might know that there are 128 ounces in a gallon, but don't usually put that on a flashcard, do we? All right, then 8.4 is the easiest because it's time, and everybody knows time involves 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. But then we also have a problem with weeks to a year is about 52, so we're not going to do those. But we will do days in a week and so forth. Very familiar. And so we would do a lot of time conversions in primary math. How many days of what are the days of the week, and so forth. So we can apply this to our conversions. Let's say that I don't know, I'm going to convert. Seconds is a very instant of time, isn't it? Let's say I have 4,500 seconds. Seconds is no longer abbreviated SEC period. We've kind of gotten on the metric bandwagon, and you're not going to see that. You're going to see an S, no period. Okay? Same thing with hour. Hour is no longer written HR period. It's simply an H, and your textbook does so. Okay? I'm still in old-fashioned SEC period, but that will not be seen. You know, us Americans, I'm not going to say 4,500 either. What did I just say? I said 4,500. So you're going to see 4,500 seconds written like this. How many hours is that? A lot. So I'm going to convert out 1 second. Sorry. I want seconds. We've got 60 seconds in 1 minute. Now, we're still using MIN because otherwise if I just write M, what is it? It's a meter. But I'm not putting a period anymore. Okay, so I'm trying to stop and get out of the habit of putting the period. I'm still doing it. But you'll notice in your book that they will not put the periods and they won't put we'll just use S and H. So I'm going to set this up so the seconds cross cancel. I still don't have hours. I'm going to now set it up so that the 60 minutes in 1 hour. Okay, that's looking foreign to me still, but we'll try to use it. All right, then this is going to help me because I'm not going to divide by 60. I'm not going to divide by 3,600. I'm going to cancel this 0 with this 0. I'm going to cancel this 0 with this 0. I'm going to reduce. 3 goes into 6 twice. 3 goes into 45 15 times. And I still have another 3 in this 6 and another 3 in this 6. 3 goes into 6 twice. 3 goes into 15 5 times. I don't have a whole lot of math here left to do. Left in the numerator is a 5. Right? Left in the denominator is a 4. The unit that remains is an hour. It's only an hour and 15 minutes. Okay. So you will be seeing a little bit more of the multiple conversions in the hour, in the time section. See how I'm going to do the fraction math. Not only does it make my division go away, essentially, it also is going to help me have it all organized and get the correct answer. What if I have 2 2/3 day? Okay, you're going to see that they don't abbreviate. This book writes it out. Okay, I've seen it DA period, I don't know, but we'll just go ahead and keep it consistent. How many minutes in a day? So how many minutes in 2.5 days? I'm going to do fraction math. This is going to be 8 days over 3. 2 2/3 is 8/3. Then I'm going to set it up to how many hours? First, I'm going to get rid of 1 day is 24 hours. And then I'm going to get rid of hours and get it to the minutes, the unit that I want, the minutes. So I know that 1 day is 24 hours, 1 hour is 60 minutes. So what I'm going to do is I'm going to get rid of the 3. 3 goes into 24 8 times, and then the days canceled out, the hours cancel out, the unit that I want, minutes. I'm going to scoot this over, it's not going to be enough room. The minutes remain. 8 times 8 is 64. And then 64 times 60. Remember, when you multiply with a power or with a multiple of 10, I can just bring the 0 down. You should never be filling zeros in your partial product. Then 6 times 4 is 24. 6 times 6 is 36. So it's 3,840 minutes. Okay? But I did cut down on some of the math. And you can't use the decimal. You can't use 2.6 or whatever you might want to try. Use fraction math. All right, so your homework does entail 8.1 through 8.4, the evens in just the objective A, and your quiz will be over measurements. There are some other things that I want to see you do with measurements, and that involves fraction math. Okay, so we do need to be familiar with compounds, because we can't use a decimal. We're talking in intermediate math about giving a pep talk of how much better the metric system is. And that's because the metric system doesn't deal with compounds. If I talk about how tall somebody is, it's going to be, 1.7 meters. Oh, not 2. That's too tall. 1.7, I don't know why I wrote 2. I did say 1. 1.7 meters in the US, what are we going to say? We're going to say 5'9". 5 feet, 9 inches. Bit clumsy, isn't it? So if we are working even for us, we have to be able to put this in terms of the larger unit. So to put this in terms of just the larger unit, and we're doing US customary, we are going to use not a decimal, that's metric. We're going to use a what? Mixed number, yes, fraction. We're going to put that 9 into fraction form. The whole number will be the feet, the larger unit. The smaller unit has to be put over the conversion fact, doesn't it? And then, of course, we have to reduce it. The inches cancel. 3 goes into 9 3 times. 3 goes into 12 4 times. See how that works? The US customary units is fraction-based, even when we're dealing with what would be called a compound measurement, 5 foot, 9 inches. We may find our useful for our purposes to turn it into the smaller unit. The smaller unit, we are still going to multiply by the 12 inches. Okay, so 5 times 12 is 60. But then we have let me move this up. 5 feet times 12 inches, which is going to give us 60 inches, plus the 9 we already have. So we have 69 inches. So we need to be able to express our US customary unit in 3 ways. Larger unit as a mixed number, compound in each unit, larger unit. Okay, so if you're 5'9", you're 69 inches tall. Okay, how tall are you, Amanda? 5'8". Are you sure? How tall are you, Desiree?
5'1".
5'1". Okay, so how tall is Desiree? She's 5 1/12 feet tall. Only 61 inches. I used to be 5'9". I'm kind of shrinking and slouching, but.
Do I need to add a half onto my height then?
No, we don't want it. We don't want it.
8.5.
Oh no, you round up.
Yeah, so technically
I was thinking you were 5'9". Okay. And anytime I do height, I always bring up Miss Mayville. How tall is she? 4'11"?
Short,
4'10"?
short.
So we can, with primary, of course, we have all kinds of fun with this, and we do need to start bringing up the compound units. So I want you to be able to do the U.S. customary conversions and a little bit of manipulation with the compounds, being able to understand, and I want you to do everything in the form of fraction. Fraction answers, mixed number answers, fraction formatting, because the U.S. customary units are clumsy. They're arbitrary numbers between them. That does not apply to the metric system. The metric system, everything is on a power of 10, and so is our place value. So I would never write 1 meter 7 decimeters, ever. So these two systems are totally different, okay? Now in primary math, we might learn that a kilometer is like a mile, but we're not going to be doing anything with metric because it's decimals, and we don't know decimals. All right, so we may teach them a few metric prefixes and a few names of metric units, but that's about it until their math catches up. Another thing that you're going to notice with the U.S. customary units is we won't do decimal computations. We will do fraction computations. So if I have 2.5 gallons of who knows what, paint, and I paint part of my room, and I use up 1 gallon and 1/5. How much paint do I have left? Fraction math. So that means common denominator, doesn't it? So that's going to be 1 3/10 of a gallon. So anytime you are doing any computations or you're doing any converting with the U.S. customary system, fractions, fractions, fractions. No decimals allowed in chapter 8. No decimals allowed on quiz 7. Okay? Fraction math. And so that's why we don't do a whole lot of conversions and things in grade 2. We're going to talk next time about teaching primary measurements and teaching, introducing them, which is kind of a part of early childhood education, but third grade learns how to do these conversions. And third grade, though, pretty much is going to protect the students from remainders. We protect our third graders from remainders because they don't know how to do fraction math yet until 4th grade. But we just learn how to do things, and we're always going to make sure everything divides out evenly. But it's still going to be fraction based. And in 3rd grade, we have to do larger to smaller multiply because we can't do the cancellation of units. They can't do fraction math. That's why we have to have all those crutches for primary math. Walkers. Okay. All right. So that is a good technique for you to learn anyways. Because if you have to convert units that you don't know, that you're not familiar with, how are you going to decide larger to smaller multiply? Well, you have to look at the conversion fact and say, okay, since that's a bigger number, that means that this is the larger unit, so that means I'm going to either divide or multiply. So cancellation of units even works on other things. So make sure that you start doing your measurement computations properly, and that is fraction math, and that also is, don't treat the units as an afterthought. The units are part of the computation. That's why if you did your units poorly in grade school and even in junior high, you had a really hard time in high school physical science. And you probably didn't take high school physics, okay, because the math was causing you problems. So make sure that you are setting a good foundation, because what have we said over and over and over in primary math? You're teaching from scratch, right? And you have to dig and pour the foundation. So from the very beginning, even with our measurements, we want to do them properly. Gallon is not a label. It's part of the problem, okay? It's not like, you know, Susie has 4 pencils, Billy has 8. How many more pencils does Billy have than Susie? Pencils aren't units, and so they are labels. So make sure that you start approaching your measurements properly. So you will need to know your US customary conversion facts and be able to convert with them in fraction format.